Hi boys and girls, this is Miss Richardson. Today we're going to be working on lesson 13.3, how to find the area of combined rectangles. Last week we worked on area with just a simple rectangle, and today you can see in our first diagram we have what we could look at as a set of combined rectangles in this odd shaped polygon. So let's take a look at the story. It says Jan is visiting a botanical garden with her family. The diagram shows two rectangular sections of the garden. What is the total area of the two sections? There are definitely different ways to find area of combined rectangles. One way is to count square units, excuse me. Now that would include using some grid paper, which you may or may not have at your house at this time. If you do, you can certainly apply this strategy in some of your problems. If you don't, that's okay. I'm going to show you anyway how you could do this with grid paper. First thing is to simply redraw the figure you're given, in this case the garden, onto your grid paper. So in the original it went down 7, so you would count down 7, and then across 4, and then up 4, again just like in the original, and then over 4 and up 3, and then over 8 to close it off. And they're even showing you that dividing line to separate the rose garden at the top and the herb garden at the bottom. So if you have grid paper and you draw this out like they're showing you, you would simply count the square units. How many squares are in the rose garden? You would just simply count them up, and you would count 24 square meters. And same for the herb garden. You would just simply count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then to find the area of the combined space, you would add. Right? When we combine things, we add it together. So you would add 24 plus 16 in this case, and you get 40 square meters is the area of these combined rectangles in the botanical garden. Again, I realize a lot of you don't have grid paper at home, and that's quite all right. So let's go back to those formulas we used last week to solve the same problem. Remember our area formula, area equals base times height. We're going to apply that here. So we're thinking back to the garden up top, the area of the rose garden first. The base is 8, the height is 3. So we do 8 times 3 equals 24. Then for the herb garden, the base is 4, the height is 4, says so right there. So we would do 4 times 4, and that equals 16. And again, we want to find the area for the whole space, so we just add those together. 24 plus 16 equals 40 square meters. So whichever way you solve, whether you're using grid paper that you might have at home, or you're using your formula of area equals base times height, either way you would add the two smaller rectangles together to get your final answer for the whole space. In this case, 40 square meters. Let's do another practice using some addition again. So, here you can see our problem. Here you see in this lovely orange color, Greg is laying carpet in the space outside of his laundry room. I'm guessing this is probably not the color of his carpet though. The diagram just shows us where the carpet will be installed. The space is made of combined rectangles. I think in your mind you could probably see where we could divide this odd shaped polygon into smaller rectangles. So we're going to use that addition method again, thinking of our formulas. And if you didn't already do so, you could write down those formulas on a piece of paper, or maybe you have them saved from last week. They will be in your Google form as well, but it's always good to have them handy when you're thinking about using formulas. Okay. So stop here. So this is saying that we can use addition or subtraction. Let's practice that addition method one more time before we try a new method. So again, if we want to use addition, we're taking that original odd-shaped polygon and we're splitting it into now two smaller rectangles. Because we remember from last week how to find the area of a rectangle. Area equals base times height. So for that smaller rectangle A, right, the base is 9, the height is 8, right? So 8 times 9. We know our basic facts, so we know that that is 72, in this case, feet. Then for rectangle B, same formula, area equals base times height, right? The base is 16, the height is 17. So you do 16 times 17, okay? Now, as you're working on your own, I would expect that you would write that out, do some good multiplication practice, and you would find that the answer there is 272. So then we're just going to add those together. All right, we broke it apart into two smaller rectangles. Now we're going to add them together to find the total area of this odd-shaped polygon. Kind of reminds me of when we did partial products in multiplication. We broke apart a big multiplication problem into two smaller ones, and then we combined them back together with addition. That's what this reminds me of. So up above it did say that we could use subtraction. Well, think, how can we use subtraction to find the area of this odd-shaped polygon? Well, we could pretend for a moment that this was one big rectangle. Use different colors so that really stands out for you. Pretending that this is one big rectangle. Right here they're just referring to it as the whole space. You can think of it as the whole space or the whole rectangle. So if we were to find the area of that whole space, right, we would think, okay, 24 is the whole base, 17 is the whole height. So 24 times 17. And again, I would expect that you would calculate that and solve. In the interest of time, I will just tell you the answer in this case is 408 feet. Okay. Now, if we're finding this whole space now, but Greg doesn't need to know the whole space. He only needs to know this odd shape. He doesn't care about what's up here. So we don't need to know this. We're going to have to subtract that out of what we just did. So let's use our formula again. Area equals base times height to find the area of this missing section. They're calling it in the book, or the extra space, right? So as I mentioned before, you're always going to have all the information you need in these diagrams to help you. So right here, the arrows are pointing to this side and this side, the base and the height of our missing section. So we can figure out what that would be with our formula, 8 times 8. So this missing section is 64 square feet. Greg doesn't need to put carpet there, so we're going to subtract that from the entire larger space. And again, you would write this out and calculate it, and you would get, whoops, oh, where's my pencil? You'd get 344. So again, bringing that back to our story, the area of the carpeted space is 344 square feet, whether you use subtraction or addition. Okay. Let's do just a couple more problems to practice. And I've got this set up here. Let's have a little less, let me cover this up so that we're just seeing one at a time. So our directions are asking us to find the area of the combined rectangles. So let's do one practice with addition. I've kind of laid out where I want us to go with this. Okay. So again, sometimes I like to think first and think, okay, how could I split up this odd shape into smaller rectangles? I could extend this across here, or I could extend it this way. I think I'm going to go with that vertical split this time around. So I got to make sure, do I know the length of all these sides that I would be using? So if I call this rectangle A, okay, I see that my short side is 3 millimeters, but what's this longer side? Okay, well there's a 12 millimeter label here, but that's this whole side. I only want to know this much of it, right? So down here it's labeled 6 millimeters. Well, this whole thing is 12 millimeters. I could, that's 6, this must be 6 also. So to find the area for rectangle A, I would do 3 times 6, right? The base is 3, the height is 6, the area for rectangle A is 18. And then for my rectangle B, I'll call this larger one rectangle B. 6, I remember from before, could be the base, and 9 is the height. So I can do 6 times 9, and I know that that is 54. There goes my pencil again, my goodness. So, 54. Okay, so then I add those together. 18 plus 54, so the area of the combined rectangles is 72 square millimeters. Okay. The other method we tried was subtraction. Okay. So here's another figure. Zoom in a little bit for you. There we go, that's a little better. Okay. So we see that this side is 10 miles, 9 miles, 18 miles across the longest side, then 7 miles, 8 miles, and then this arrow here is telling me that this little section is 2 miles. Okay. So if I wanted to use subtraction, I could again pretend that this is one big rectangle, kind of filling in that empty space, right? So if I'm going to find the area of the whole rectangle, say that the base is 18, the height is 9. So I'd be thinking about 18 times 9, which I don't expect that you have memorized, but we would calculate that on paper, and we would get that that is 162 square miles, excuse me. Then, right, we do not need to know this section here, so we would have to find that area and subtract it, take it away. So I know that that would be 2 times 8 for that missing section, the extra part that we don't need. 2 times 8 is 16, so I would take the area for the whole rectangle, 162, minus that missing section, and that would equal 146 if I was to go with just the part that I needed. Here, in this case, the green part is 146 square miles. Here's one more type of shape you might see in your practice problems, where in order to find the answer, you would have to make more than 2 smaller rectangles. The same rule would apply. You would still break apart your odd-shaped polygon into smaller rectangles, find the area of each rectangle, and then add them together. Or, if you like the subtraction method, pretend for a moment that it's one big rectangle, find the area of the one big rectangle, and then subtract that extra part that you do not need. So in this case, I might want to make a little rectangle A here, and then maybe I'd make this rectangle B, but wait, that's not a rectangle. I need to make a third rectangle, so maybe I would draw a line here. And maybe that's rectangle C. So I'd find the 3 smaller areas, add them up, or find the big whole rectangle and subtract what I don't need. So that's 2 different ways. You can use addition or subtraction. You only need to use one or the other. It's 2 different methods. Or possibly you might at home have some grid paper and you want to redraw it counting the number of squares that it tells you each side should equal. So you get to choose which method you like the best. Maybe you want to try out different ones like we've done in class many times. We're teaching you several strategies. you try out different ones and see which one you like the best. These problems take a little bit longer, as you can see, so we're only giving you 6 problems to work with today. So take your time, don't forget your formulas, and enjoy working with area. If you have questions or trouble, reach out to your teacher, boys and girls. Have a wonderful day.